All right, friends, we're going to talk briefly about interval and radius of convergence for some of my alternating series. And I want to touch on the endpoints. I think in both my sections, we sort of ran out of time when we were looking at them to talk about what to do with the endpoints. We want to be very, very careful there. So let's suppose you had the infinite series. We'll do something relatively simple to start. Let's suppose we were talking about this, and the goal is to say, for what values, x does the series converge? Okay, and so we're going to want to use our ratio test for absolute convergence, right? Because this this could be an alternating series, right? Depending on the value of x, this could be an alternating series, right? So we're going to look at L being the limit as n goes to infinity of that nth plus first term, that nth plus first term over that nth term, right? And we want that thing to be less than 1, right? So if we think about what the n plus first term is for this particular series, right, we're going to see something like n plus 1 cubed times 1 kind of disappeared, times x to the n plus 1, right? And we got to throw some absolute values on that because, again, we don't know. X could be negative. If x is negative, we need those absolute value bars or else we're going to get ourselves into trouble. And then, Mr. Mean here is making an absolute racket. And then we have n cubed here on the bottom times x to the n. Okay. And we wanted to think about which pieces could come out. And n, remember, n up here is meant to highlight that. N is always positive, right? N is always positive. It starts at 1, so we can sort of pull some stuff out, right? We can pull some stuff out, and I can pull out the n plus 1 cubed over the n cubed. And then in here, I'm just going to be left with x to the n plus 1 over x to the n, which is, of course, is just x. Well, this highlighted portion here, if we look at the limit of that, the leading terms would both be n cubed, right? So that's just 1. It's just 1. So this actually just is the absolute value of x. Okay? And we might run into some trouble here, though, with my endpoints. So remember, we wanted this thing to be less than 1. And so we know if we were to graph that on a number line here, we'd have -1 and 1. And we'd sort of be dealing with this area in between. And those are all the values of x where this thing should converge. And if you think about it, that should make sense, right? If you think about if I have like 0.5 as my x, I raise that to the infinity, right? That's going to be really, really small compared to, it's going to be smaller than n cubed is big, if that makes sense. So this thing would certainly converge for values in between there. But what about these endpoints? We sort of have to check them. So we are going to do two sort of explicit plugging ins here. So if x equals -1, and then we're going to examine that series and say, do you converge or diverge? So let's think about this series right here. N cubed times -1 to the n. Well, that's the alternating series. Where these terms are going to get progressively bigger and bigger and bigger and bigger, right? So this thing diverges, and I'd say the terms don't approach 0. Remember, we need the terms to approach 0 for an alternating series, and we need them to be decreasing, but the terms don't approach 0, right? So that diverges. So that means -1 is not in my interval. -1 is not in my interval. Let's check 1. So if x equals 1, we wanted to check this friend. And this very clearly diverges, right, by the divergence test. So even though 0.9999999 for x would work, right, these guys are both not in my interval. So my actual interval is just -1 to 1, and it does not include the endpoints. Okay, let's look at the first example. We'll just look at one more thing. Let's look at the first example from our sheet of 4 things I'd like us to retry, sort of, now that we have this machinery. Okay, so let's look at this one. This one's a lot more complicated. There's a lot going on. we can certainly tackle it, okay? Negative 1 to the n plus 1 over n times x minus 1 to the n. So we know just by eyeballing these, and I always think it's sort of good to, as an exercise to sort of try, I know this thing's going to converge for 1, because every term is just 0. And so it's going to be looking at things around 1 probably that we're going to be scared of, here, okay? So let's look at that test again. Let's take the absolute value of my n plus first term. We got to be careful. N plus 2 over n plus 1 times x minus 1 to the n plus 1 in absolute value over the nth term, negative 1 to the n plus 1 over n times x minus 1 to the n. Okay, well, absolute values things, we don't care about this, right? So let's just cancel them right away. These n pieces can come out, and I'm going to skip a few steps in here to keep this screencast a little bit brief, okay? But I'm going to be left with n over n plus 1 times the absolute value of x minus 1 to the n plus 1 over x minus 1 to the n, right? Well, that's just 1, that n over n plus 1. So this is just the limit as n goes to infinity, the absolute value of x minus 1. And again, we said, hey, look, this thing should probably be centered around 1 because that makes this highlighted portion up here equal to 0. Okay. So again, we want this thing, this thing which doesn't need that limit notation anymore, to be less than 1. And again, we're still concerned about that equality piece. So this means that 1 is sort of my center, and I could go 1 unit in either direction, and I know that I'm going to be dealing with these guys inside. But what about my endpoints? Well, if x equals 0, what series am I actually dealing with? I'm actually dealing with this series, this alternating series. That might take some unpacking there. Okay, let's look at it. If and then sorry, we're also going to need to know if x equals 2. Let's look at this guy. Okay, so if x equals 0, we end up with this series. Now, I'm going to claim that these highlighted pieces here have to be equal to negative 1. Have to. Right? One of them is going to be negative. The other one's going to be positive. They have to equal negative 1. They have to equal negative 1. Okay? So this is going to end up being... Oops, I forgot my bounds up here. Negative 1 over n. The question is, does that converge or diverge? Well, if 1 over n diverges, so does negative 1 over n. So this guy diverges, right? And say because 1 over n diverges by P series. Okay, and that tells me, right, that 0 is not included, because this thing diverged. Again, we were after where does it converge. So let's look at my other friend here. This is the alternating series, negative 1 over to the n plus 1 over n. And what do we know about that? By the alternating series test, this converges. This converges by alternating series. So it's the first one we've gotten today that converged, meaning this value should be filled in, and my interval of convergence is 0 to 2 with a bracket. So we have to check those endpoints. Because sometimes they're included and sometimes there's not. By the way, the radius of convergence, if we're ever concerned about that, such a thing, right? It's simply saying, hey, look at the middle here, that's 1. How far from 1 to the endpoints? That's also just 1, right? So r would be 1, right? Because if you can think about in my picture up here, this is 1 and this is 1. So you could think about my diameter being 2, if you think about a circle, but my radius would be 1. All right. I'd like you to try the other 3 of those now, though.